In this video, we'll be going over the memorization approach of unique paths 2. Now let's go over the thought process. The recursive approach was inefficient due to overlapping recursive calls. We can avoid overlapping recursive calls using memorization, which means caching. So what do we need to cache? In each of the recursive calls, we are trying to find the number of paths at the current cell. Find the number of paths to reach the bottom right corner at the current cell RC. This means we can cache RC with the number of paths. Now let's go over the pseudocode. So we're going to create a 2D matrix, Memo, to cache previously calculated results. So the rows represent R, the columns represent C, and the values represent the number of paths. Now we're going to fill Memo with -1. This is to prevent the case where we have found 0 ways to reach the bottom right corner. We have failed to find a path from the top left to the bottom right. This can maybe due to obstacles. So we're going to implement the top-down memorization approach. Then we pass in our Memo, so it's a cache. Now what's the base case? If Memo RC is not equal to -1, which is not equal to the default value, that means we have already found the number of paths for the current cell. We do not need to calculate it again. So we can return Memo RC. Then we need to cache this. So we're gonna put the sum of the two recursive calls inside the cache, and then we can return the result. Now let's go over the time and space complexity. So let's go to 2mn plus mn, where m and n are the number of rows and columns. So the first mn is to fill the Memo with -1. And the second one is there are m times n possible states with R and C. Now let's go over the space complexity. Let's go to, first is our Memo, so mn, and then plus O of m plus n, which is our recursive call stack memory. Our total space complexity is equal to O of m times n. So this one's for Memo, and this one's for recursive call stack memory. Now let's go over the code. We are first going to create our cache. So let's move these two out, the number of rows and the number of columns. Now we're going to create our Memo. Then we're going to iterate through to fill Memo with -1. We're going to pass it in. So first pass in the total number of rows and columns, and then the Memo itself. And we need to update our method. So if Memo RC is not equal to -1, we have already calculated the result for for the RC, so we can just return the result, the cached result. Now we want to cache these two results inside Memo, so we can just place the sum inside here, and we can return it. Let me know if you have any questions in the comments section below. We will be going over the bottom-up approach of unique paths 2 in the next video.